Hello there, my name's Carl Freund with Cambrian-AI Research. And once again, I have a video for you to learn a little bit about what's going on, in this case, within IBM Research. And to help us with this, we have Mukesh Kare. He's the Vice President of Hybrid Cloud at IBM Research. Welcome, Mukesh.
Thank you. It's great to be here with you, Carl.
Great, great. Well, your team has been very busy with everything going on in the semiconductor industry lately, between the CHIPS Act and just the funding that's going to provide, and IBM's role in all kinds of interesting things like quantum computing and AI engines and so forth. So, but today let's talk about the IBM stack. Let's talk about the full stack. Why don't you start there? Just tell us what you mean by the IBM stack for AI.
That's great, Carl. So just let me explain at a very high level. IBM has three businesses. IBM Stack, which is IBM Stack. We have IBM's infrastructure business, IBM software business, and IBM consulting business. So three businesses. And essentially, three businesses work with each other. That means, software business can leverage our infrastructure, which is our, can call it hardware and platform business, and then consulting on top of it. We always, as our consulting and as we work with our clients, and once we understand their problems and what type of challenges that they are facing, it gives us an opportunity to co-develop hardware and software. And that's the way you can come up with the best possible solution for your client. And that's why, IBM has always been working on a full stack approach, so that at the end, the goal is, hey, client wins when we develop best solution by co-optimization of all pieces of the puzzle, not just one part of the stack.
Interesting. So, it's funny when I have conversations with folks and I tell them that IBM Research is a client of mine, and they're like, well, I thought you did chips. I thought you were focused on chips. I didn't think IBM was in the hardware business. I'm like, no, by all means, IBM's in the hardware business. Why don't you talk about the role of semiconductor development and research in IBM and how that's important to delivering the full stack?
Yeah, that's a great question. Now, just to connect with the full stack, you see that the fact that hardware and software co-optimization is so important. In fact, many of the software companies as well as cloud companies are designing their own semiconductors now, right? It's the journey that they are starting versus IBM. IBM has been in the forefront of semiconductor since the beginning of semiconductor, right? It's the IBM's scaling principles that defined how to scale transistors like 50 years ago. Or, IBM invented the first DRAM capacitor. Like that's how the word DRAM came out in the world, right? So IBM has always been in the forefront of semiconductor innovation. And what it does, and we have always been investing and continuously improving our business model so that at the end, we are coming up with the best solution for our clients. And in this case, once we understand our clients' need from the workload point of view, then we can then translate that into what's the right software and what's the best hardware or the chip technology that we need to develop, so that at the end, the right chip technology can accelerate the best software and eventually best application for our client. And that's why chip technology has always been very important to IBM. We continue to invest in chip technology, and we continue to work on this co-optimization of hardware and software for IBM Stack to deliver best solution for our clients.
Interesting. So when I think about IBM Research, I think about all the partners that you collaborate with, some really big names and some small names. How do your partners leverage the chip technology that IBM is delivering or researching in IBM Research?
Yeah, well, IBM has, I will say, this is another area that we pioneered. In fact, IBM has been partnering in chip technology for more than 30 years. In fact, IBM started partnering in the DRAM world when we used to manufacture DRAM technology with with many companies like Japanese company as well as European companies. So we have essentially always understood that partnering is the best way to develop the most optimal manufacturing solution for our clients. And the reason we partner is because our partners bring different perspective into developing technology. IBM has a perspective. We are good in certain areas, but we are not good in everything that is needed for the entire supply chain. So in semiconductor, as an example, now we partner with not only the big chip companies, but we also partner with equipment companies, material company, design company, EDA companies, because they bring in perspective that is very different and than what we would bring purely from a product and from a chip side. So it's the thing that we really enjoy and we really help us develop best solution is the knowledge sharing, is the co-creation in the entire supply chain of semiconductor. And that's why we have been partnering. The key to this partnership is that anything that we develop together benefits our clients and their clients. In other words, all our partnership for co-development is geared towards a product, whether the product can be IBM's product, like our systems business product or our cloud business product, or it could be a product for an equipment company for their equipment that they're building or the new material they're building for their product. So that keeps us grounded, and this partnership brings the best talent together to eventually develop the best technology for all of our clients. So that's the model that we've always been on.
Interesting. It also increases the likelihood that the research will produce something that is of significant business value for somebody because of that tight collaboration you have with the partners in IBM Research.
Yep. And also it gives the model is also shared investment. So what it does, it also reduces the risk for each of the partner who are investing or co-creating this technology. So good for client as well as good for companies who are partnering together.
Excellent. So when I think of hardware at IBM Research, obviously the quantum computing, which President of the United States visited you yesterday and saw the quantum computer up close and personal with Arvind Krishna. So that's kind of a superstar, but there's lots of other hardware technology that you're investing in, from analog AI, for example, and reduced precision AI, that you've made some significant announcements regarding the capabilities of reduced precision AI. Can you give us a couple of use case examples of reduced precision computing?
Yeah. So Carl, this is first of all great that you pointed out. We were so excited and so thrilled that President Biden was visiting IBM site in Poughkeepsie, New York. That's where the world's most powerful computers are built. Our IBM Z mainframe computers are built in Poughkeepsie, as well as quantum computers are built in Poughkeepsie. So it's fantastic that we could host and share all the work that we do in Poughkeepsie, where we actually build and manufacture those computers in the US. Now, talking about reduced precision computing, this is an example of IBM's full stack approach. When we started to work with our, IBM's clients are, the big clients are in regulated industry, in financial sectors. And as we talked to our client, we understood there are certain needs that these clients have. That is, they want capability like AI capability in transaction. So during transaction, they want to be able to run AI model for things like fraud detection or anti-money laundering or credit card authorization. So there was no such capability that existed before. So we understood these needs from clients. On the other hand, IBM Research pioneered a technology, this reduced precision technology in 2015. In fact, we wrote the first paper in ICML conference in 2015 on how we can reduce number of bits used for computation or reduce precision without losing accuracy. We want the right answers, but we don't. Is it possible to use less number of bits? So we combined our research knowledge that we have been building for last several years and understood the client need that they wanted very fast AI capability during transaction. And we converted that into a accelerator, a reduced precision accelerator that we have then implemented that acceleration inside our Telum microprocessor, which was announced in 2021, actually, microprocessor, which now has a inbuilt low precision accelerator. And then the system that was built around it, IBM Z16 system was built around it. And that system got shipped with this capability earlier this year in April-May timeframe in 2022. And now what client can access is that during transaction, this low precision accelerator essentially accelerates AI inference capability for different type of needs, like I talked about, fraud detection or anti-money laundering or compliance testing. There's many such cases where you want to run AI model, but very fast, maybe 10 times or 20 times faster than what it can be done on a regular CPU, and get the results back to client within a few millisecond latency. And that's a technology that we are very proud of, that all the way from, on one side, from fundamental research to getting that into product, on the other side, from a full stack approach, understanding client problem, and then marrying the two things together and building a product and implementing it in our Z16 and bringing it to our clients as a full stack solution. So that's a very exciting part of our project, and we are very proud that we can bring this technology and this solution to our clients.
Yeah, that's pretty cool. So you can actually conduct analysis of data on the fly in the middle of transactions as you process those transactions.
Exactly. That's exactly.
Doing it offline and calling somebody up later and saying, hey, that credit card you just ran, we're going to deny that now because it's turned out to be fraudulent. So that's nasty fly, excuse me. So that's pretty cool. That's very, very cool. Anything else you guys are working on right now before we close that you'd like to share about the development of the full stack approach at IBM?
Well, there are many things in the pipeline. This is one example, that I wanted to share with you. Obviously, we are developing leading edge semiconductor technology. Last year, we also announced 2 nanometer chip technology in partnership with many partners in our ecosystem at Albany Nanotech. And you will see that, that same concept, this concept around gate-all-around nanosheet device architecture implemented in 2 nanometer is now getting adopted by all the chip manufacturers. And you will see, benefit of such technology into our product as well as products of our partners as well.
That gives you a much bigger footprint in the industry and impact on the industry, having fundamental technology like that everybody else licenses and picks up and uses themselves. That's great. That's great. Well, Mukesh, thank you very much. I have a feeling we'll be doing more of these calls in the near future as you guys continue to innovate at IBM Research. So thank you very much for your time. Stay safe.
Thank you. Thank you very much, Carl. A great conversation.